The ages of 8 students in a line dancing class at the YMCA. Here they are. 76, 68, 70, 78, 73, 68, 69, 74. There it is. Calculate the mean and the median. Can you know how to do the mean? Yeah. How do you do the mean? Go. Ready, go. Make it happen. You have calculators. You don't even have to do it in your head.
No, you don't. That was a complete guess.
You didn't do the work too, so you can't get credit. You still didn't do the work. Michelle.
Yeah, that's what I'm saying.
So the mean, now remember in stats, do you remember, I don't know, did we talk about the symbol for mean?
Yeah.
Well, mu is the mean for a population. X bar, 72. X bar is 72, so my mean of the ages is 72. Now, how do you go about finding median? It's the middle number. So, do I just find the middle of this list right here and go?
Yeah.
What do I have to do first?
Well, if there's two in the middle, you add them and divide.
Yes, that's true. So I can just do it like it is?
No, you have to order them from least to greatest.
You have to order from least to greatest first. Then you do that thing. All right, so let's order them. So we get what? We have two 68s, a 70. Oh, wait, a 69 in there. 78. 6, 7, 8. All right. And then, boop, boop, boop. Find the middle. Wait, yeah, so there's two middles, right? It's an even number. So you average them, and you do get 71.5. So that's what we say, we call the median. Median doesn't have a fun little symbol. We just say mid. It's not mid, it's median, right? All right, so now look at them. What would you say about the X bar and the median? How do they compare? Pretty darn close, aren't they? So if I had to make, if I had to make a dot plot, what shape would it be? Symmetric, and you know that because the mean and the median are pretty much the same. Yeah? All right, good. Now, range. What's the range of the data? How do you find range?
You take the highest number and the lowest number and subtract.
So max minus min. So 78 minus 68, you don't need your calculators, it's a 10, right? Now I will say this about range. Range is a calculation. So like when you're doing socks and you're talking about spread, if you want to say range, that's fine, but you have to be able to calculate range to say it, right? So you have to literally know all the pieces of data to find the max and the min somehow in a table or whatever. You can't say the data has a range of 0 to 80 or whatever. That's not range. That's a spread. All right? That's where it gets nitpicky. Range is a calculation, so it's one number. It's not something to something else. It's one number. See the difference? Haven't counted off for this yet because we're having the conversation now. All right? But range is a calculation, and honestly, we won't use range a whole lot because it's a middle school thing, and we're AP. So there's range, there it is. We're going to focus on standard deviation, and the other one we're going to focus on is IQR, two statistical measures of spread that are more sophisticated. So standard deviation. It says finding range is helpful, but it doesn't tell us how spread out the data is between the minimum and the maximum. How can we find the average distance of the values of the mean? Well, here's the table. Here's kind of where to walk you through the process here. You have your values on the far left. In the middle column, we're taking said values and we're subtracting the mean or the average, right, that we said was 72. See it? And then we take that difference and we square it. Right here, we square it, right? So the first 4 values are done for you. Let's do the next 4. And then we're gonna add them all up and get the total right in here. All right? Ready, go. Use your calculators if you need to. What? So this is done through 78. So like I'm going to do 73. 73 minus the mean of... Everybody know what you're doing? If you don't, say the word. Word.
Do we have to write 68 again?
There's two 68s. No, you do. You have to account for both of them. Total is 102. Yes, it is. Okay, then what would I need to do to the 102 to find the average? Divide by the 8 pieces of data, right? So 102 divided by 8 gives me 12.75. That's the average distance from the mean. But that's not standard deviation. Standard deviation goes one step further. It's going to take the square root of that. Why do you suppose we need to take square root? Because we squared them right in there, right? Can you think about why did we square them?
To get them out of the negatives?
Why would that matter? We don't want them to be negative. Why do we not want them to be negative? You're right, you're right.
Because you can't.
Yeah.
Never thought about it. Let's think about it. We're talking about distance from the mean. Can distance be negative?
Negative distance is other way.
Distance can't be negative.
Oh,
Right? Distance can't be negative, so we have to square it, and then we undo the square at the end. Okay? So when we square root 12.75, I get 3. Come in. What did I get? 3.57. All right. Now, the formula for standard deviation, don't let it scare you. It looks like this. No, you do not have to memorize this. Do not panic. It's the square root. Didn't we just take the square root?
Yeah.
Yes. All right, so the top looks like this. It's the sum of,
Sigma.
sigma means sum, right? It's not that sigma. It's always somebody. Minus x bar squared, all of it over n. All those symbols look crazy, don't they?
No.
Here.
What does n mean?
What does n mean?
Oh, the terms.
The number of terms. Number of terms. N is sample size, number of terms.
That's not a very hard equation to remember.
It's not?
Do we get a
You
sheet
got it?
on the A?
You get a formula chart, yes. You will not need this formula. It is locked into your calculators. You don't have to do this calculation anymore, but we needed to walk through it once so you kind of know. And you can begin to really appreciate those little calculators you got. Just you wait. You're going to learn all those sub-menus in there this year. So much stuff. All right, so there's my standard deviation. Now, I want to show you in your calculators, how do you do this? So you don't have to do all this craziness again. How many of you want to do it by hand? Nobody. Wait till you have a data set of 100. No way, right? Nobody wants that. No way, Jose. All right, so here's what we're going to do. You're going to find your calculator. I'm going to find mine. There it is. Let's see if I can do this split screen. All right, in your calculators, find the stat button. Right under delete. Do you see it? Stat.
Is this made for this class?
You could argue, yeah, maybe so. All right, the first thing you see is edit. Hit enter because you want to edit. This is where we house the data. In your list 1, do you already have stuff in your list 1?
No.
If you don't, great. Anybody have anything in their list 1? Nope, everybody's empty? Okay, great. So now you can see I have listed the ages of these people in the line dancing class. So you type those in. I don't want that 16. That 16 should not be in there. I'm taking it out. Look. All right. There's the 8 ages. So you put those 8 ages in there. Calculator's going to do it for you. It is. Not the sigma you're thinking of, but that's a sigma.
Stop laughing.
It's Greek letter sigma. We will use it quite often. It stands for population standard deviation. Which value did we just calculate on our tape? Sigma, right? Yeah? You with me? Okay, so what we just found was this one, 3.57. So back on your paper over here. We're over here. Right? We found that one. Now, write down what your calculator says for the S sub x. It's 3.81. Okay, 182, my bad. Okay. Got that? Really? Alrighty. Now, what happened here? What's the difference? What do you notice? Two different standard deviations. Which one's bigger? Okay, so there's something being calculated differently, is there? All done? Okay. So here's the deal. What we calculated was this one. This was the population standard deviation. That is making the assumption that the data we entered was the entire population. Maybe it was in this case. I don't know. The calculator doesn't know what you entered. They don't know. He don't know if it's the whole thing or just a subset, right? So it calculates both. So the S sub x stands for sample standard deviation. So there's a slight difference in the equation when it's a sample. All right? So look at the equation. Here's what it looks like for sample. Tell me what's different. N minus 1. N minus 1. Because since the sample is not the entire population, there's probably some error in there, right? Yeah. Variability for sure that we have to account for in our calculation. That's why we do N minus 1. But it only happens with the sample, not the population. We good with that? Yeah. Thankfully, it's all built into your calculator. You have to be smart enough to know the difference between sigma and S sub x and when to use which one. All right? 90% of the time in here, we're using the sample standard deviation because it's nearly impossible to get the whole population's data. All right, now, we forgot to add me to the data set. In the little storyline, I'm 16 years old when I take this class. Calculate the new mean, the new median, and the new standard deviation using our calculator. How do they compare, and why do you think that is? So, I'll split screen real quick. Go back to your data set, stat edit, in your calculator, stat edit, and we're going to add a 16-year-old to the class. So add 16, hit enter, move on. Now we're going to go back and recalculate. How did we go there? Do you remember?
You just add again, go to count, and then you go to,
One variable statistics, yeah. There it is, yeah.
Did you add the 16 back in there?
Mm-hmm. Add 6, yeah. Now notice what changed.
Because the student.
Another student was added. So let's see. My new mean is an X bar of 65.78. What's the median now? 70. And the new standard deviation? 17.92. Huh. Why do you think it changed so much? So does it always change when you just add a number?
You added an outlier.
We added an outlier, didn't we? Throwing that language around. It's good. It's good stuff. It's good stuff. All right. We added an outlier. Remember we said that the average, the mean will chase outliers? It's going to go lower. This outlier was a low outlier, so the mean went down, didn't it? Went from 72 to 65. But what happened to my standard deviation? Went way up, didn't it? It was 3 point something. Now it's 17. Why?
Because you have the outline.
It's distance from the mean, right? There's a big distance from the true average from 16 to 70 or whatever it was, right? That's a lot of distance compared to the 73-year-olds. So all of that gets averaged together. So my standard deviation went way up. Mean went way up. What about the median? Did it change? So it didn't really budge too much, did it? Okay, so we call that the median is called resistant to outliers. So it's pretty reliable measure of center. So if that's resistant, what's the mean in the standard deviation? Non-resistant. Cannot resist. Got it? Because they're non-resistant, they are not reliable. Ready to move on?
Yes.
Groovy. All right, measures of center. We're summarizing what we talked about. How did we find average? Formula-wise, it looks like this. It's the sigma, the sum of all the data points divided by the sample size. The median is what you know of as the middle value, right? If it's the middle value, if there's an odd number, it's the average of the two middle if there's an even number of data points. Now, that's center variability, or it could be referred to as spread. In SOX, it's called spread, but it's still variability. We have two measures. We have IQR, which we're not going to dive into today, but IQR is Q3 minus Q1. Come back Monday for more details on that. All right. But then range, we talked about range, right? Max minus min. And then standard deviation is that lovely thing we've written many times now. Generally, we won't use range from here on out. We'll either use IQR or standard deviation. It'll either be given to you or easily calculated using your calculator. Now, in stats, you're going to be asked to interpret a lot of numbers. A lot. Here's your first interpretation. You need to lock it in upstairs. How do we interpret standard deviation? Here's like the sentence structure. Excuse me. Here's how it will read. It will read, okay, I'm just going to put in here context because it depends on the question, right? So if we're talking about these people in the line dancing class, the age of the members of the line dancing class typically varies by whatever the standard deviation value is from the mean of whatever that number is. Typically varies from the mean by what? Those are the main words we need to remember. So in a second, I'm going to ask you to practice this. Like when it says interpret, go back to this sentence every time. Obviously, the context is changing, right? Don't talk about the old people at the line dancing class in every single question because it won't work, right? Changes. Variance. Now, variance is it's a value we use, but we really don't use it till chapter 5. But it's related here because variance is standard deviation squared or sigma squared. We will use it when we get into probability. All right, now, outliers, the skew effect, center of variability. Now, which ones did we say were greatly affected by the outliers? Which two measurements? Good. Yep, the mean and the standard deviation are greatly affected by the outliers, and we call this non-resistant. So then the question becomes, when we're doing SOCs and describing a distribution, which measurements do we use if there's outliers or skewness?
IQR.
IQR for spread. What about for center? What would we use? Median. Okay, and then if it's symmetric, mean and then standard deviation. Mm-hmm. So far, so good?
Mm-hmm.
All right. I'm going to give you and your table buddies a few minutes to do these application questions, see how you do with them. Using this data down here, researchers interested in how much annual rainfall is typical in the U.S. She takes a random sample of 9 cities in the U.S. and records the annual rainfall in inches. Ready, go.
What was, yes.
Lovely. Did you get for the median 40.5?
Yes.
Yes. Everybody good?
Yes. Yeah.
Would you use mean or median to summarize the annual rainfall?
Median.
Why?
Symmetric.
It's median is resistant, and you want to use the resistant measure because it is skewed, right?
Oh, yeah, resistant.
That may be what you meant. Alrighty, and then it says the standard deviation. They give it to you. Notice they didn't make you calculate. 15.52. Interpret the data. So it should look like this. The annual rainfall for these 9 cities typically varies by 15.52 inches from the mean of 34.94 inches. Yeah? So notice context is not necessarily just one word, is it? It's annual rainfall of these cities. You want to have clear context. Do not do the very mere minimum. No. And we have units. Always include units. Questions? Can you do it? Absolutely. You can do it. Yeah?